Hey everyone, I am Abhilasha AKA TheTechGirl and welcome back to my 10th board exam prep series. In this series, I help you prepare for math exams without stress. Just a couple of hours a day and you'll be fully prepared. Today's topic is pair of linear equations in two variables. This chapter is important. It holds around 7 to 8% weightage in your board exams, and understanding this will help in algebra and coordinate geometry. So let's break it down into simple concepts with examples and step-by-step explanations to make sure you score full marks effortlessly. Stay till the end for practice questions to see whether you have understood the concept or not. Let's get right into it. So we are going to start with the basic. The first question is, what is linear equation in two variables, right? So a linear equation in two variables is an equation of the form ax plus by plus c equal to 0, where a, b, c are real numbers and x, y are the variables. Since there are two variables x and y, and this is a linear equation, since the higher power of this equation is nothing but 1. Yes, the highest power is 1 in both the cases. So this is a linear equation and it has two variables, so linear equation in two variables. Let's look at some of the examples for linear equation in two variables. 3x plus 2y equal to 6. X minus 4y plus 7 equal to 0. 5x plus y is equal to 10. If you see, all of this has the highest degree as 1, correct? That's why these are the examples of linear equations. And since they all have two variables in it, they are linear equations in two variables. Now, what are not linear equations in two variables? X squared plus y is equal to 7. Why? Because the exponent, the highest exponent, the degree is not 1. The degree is 2 in this case. Now, also multiplication of variables. Xy plus 4 is equal to 9. Since these are the multiplication of two variables, the total power, the total degree of this equation becomes 2 because 1 into, x raised to power 1 into y raised to power 1 becomes xy, and the total degree becomes 1 plus 1. So the total power becomes 2, and that's why this is not linear equation. Let's look at some of the examples, and you get to tell me whether they are linear equations in two variables or not. So our first example is 2x plus 3y is equal to 5. Is this a linear equation or not? Yes, it is, because the highest power is 1. So this is a linear equation and it has two variables. So these are linear equations in two variables. The next example is x squared minus y is equal to 4. Is this a linear equation? It is not. Why is it not? Because the highest power is 2. So this is not a linear equation. The next example is x plus 5y plus 3 is equal to 0. Is this a linear equation? Yes, it is. Is this a linear equation in two variables? Yes, it is, because it has two variables in it and the highest degree of this equation is 1. So this is a linear equation in two variables. That's clear. Now that we know what linear equations in two variables are, let's talk about solutions. A solution of a pair of linear equation is a point x, y that satisfies both the equations. So the solution represents the point where two lines intersect. What do you mean by that? Well, let's assume that we have an coordinate plane x and y. Okay. So we have, let's say we have an equation for this line, and then another one is this line, right? So I'm just assuming some random equations. So these are the line 1 and line 2, L and M. Okay. And these two are meeting at this point, P. So this point P is the solution for both the equations. because this point is satisfying both the equations. So this is the solution of a pair of equations. So let's see. Okay. Let's check whether x is equal to 2 and y equal to 3 is the solution for these pairs. Okay. How do we check that? So we put x and y value in both the equation to see whether they are equal or not. So x is equal to 2 plus y is equal to 3. 2 plus 3 is equal to 5, which is the right hand side. So yes, it is the solution for first equation. The second one is 2 times 2. So 4 minus 3, which is 1. So that's what we are getting here. So this is also correct. That's why 2 and 3 is the solution for this pair of equation. Sounds good? Linear equations can be solved graphically. Okay, so graphical representation, and based on these uh, graphs, we have three different types of solutions for linear equation. The first one is unique solution, second is no solution, and third is infinite solutions. First is called consistent system, second is called inconsistent system, and third is called dependent system. So unique solution is the consistent system. What does that even mean? Unique solution means that both the lines. So every equation, and especially linear equation, is nothing but a straight line, correct? Because it's linear, so it's going to be y is equal to mx plus c. So every linear equation is a straight line. And when two lines intersect at one point, one single point, it has one unique solution. And that is why it's called consistent system. It has one unique solution. Okay. No solution means that these two lines are never going to meet. When two lines, okay, in which situation two lines never meet? When they are parallel to each other. So these two lines are parallel to each other, and that's why they are never going to meet. So there is no solution for this pair of equations. And the third scenario is dependent system, which means the line coincides with each other. So when both the line are making the same line and they are coinciding. So let's say one equation is from here to here and another is from here to here, right? So they are both coinciding with each other. So all the values of x and y are going to satisfy both the equations. So there are a lot of solutions, infinitely many solutions. We cannot calculate how many, right? So that's when it's called infinite solutions, or they are completely dependent system. They are dependent on each other completely. So dependent systems. Unique solution, one particular unique solution, right? So line intersect at one point. When the lines are parallel, there is no solution. And when line coincides with each other, there are infinitely many solutions. Graph is a good way to find out solution. Visually, it's very simple. It helps you what kind of a system we have. But it is not always possible to draw a graph, to get a graph of equations instantly. So there are algebraic methods to solve these systems of pair of equations. Okay. So there are three algebraic methods to solve these pair of equations. First is substitution method, elimination method, and then cross multiplication method. What is substitute method? As the term itself says, substitution method. We are going to substitute one term into the another. How we are going to do it, we'll see in a minute. Elimination method is we are going to eliminate one of the variables and then figure out the value of another and then find out. Cross multiplication method is nothing but we are going to use the cross multiplication formula to figure out the values of x and y. How we're going to do, let's see in detail. Let's start with the substitution method. What are the steps to do the substitution method? We are going to express one variable in terms of the other using one of the equations. So we have these two equations. Let's x plus y is equal to 10 and 2x minus y is equal to 4. So we can write x in terms of y as x is equal to 10 minus y. Yes. And then substitute this value in the second equation. So we are going to substitute the value of x as 2 into 10 minus y equal to 4. You get 20 minus 2y. And then you solve for y here. You get 3y is equal to 16 and y is equal to 16 divided by 3. And then you back substitute it. So you put this value of y in this equation in terms of x. You get x is equal to 10 minus 16 by 3, which is nothing but 30 minus 16 by 3. So 14 by 3. And this is your x and y. That's how you do the substitution method. Sounds good? Okay. Now, the next is elimination method. What is elimination method? In elimination method, you multiply one or both equations so that the coefficients of one variable will become the same. So what you're going to do, you're going to look at both the equations and you see what can I multiply so that I can eliminate one variable completely, right? What do you mean by eliminate one variable completely? In this example, you have 3x plus 4y is equal to 10 and 2x minus 3y equal to 5. Now, what can you multiply one or both the equation with so that you have same value for one variable? So let's say we are going to eliminate x, right? So what we can do is we can multiply this equation with 2 and this equation with 3. Remember, we have to multiply both the equation on both the sides. So both the sides of equal to, so that we are not interrupting with our equation. Okay. Now the topmost equation becomes 6x plus 8y equal to 20. And the second one becomes 6x minus 9y equal to 15. Now, if we subtract this equation 1 and 2, so this sign becomes minus, this becomes minus minus plus, and this becomes minus. So plus and minus, this gets cancelled, and 8y plus 9y, you get 17y, and 20 minus 15, you get 5. So your solution becomes y is equal to 5 over 17. Ignore this. This is mistake. Sorry about that. Okay. And then you put this value of y in one of the equation. So you can just do 3x plus 4 times 5 over 17 equal to 10. And you solve this to get the value of x. Make sense? This is how. So you're eliminating one of the variables to calculate the another variable. That's why this is called elimination method. Okay. Now, the next method is cross multiplication method. The formula to do the cross multiplication is this. Your equation is ax plus by plus b equal to 0, right? So if you see, coefficient of x is nothing but a. So you're not going to use a, and you're going to do x over b1 c2 minus b2 c1, where b1 c1, a1 b1 c1 is from equation 1 and a2 b2 c2 is from equation 2. And then you will equate this with 1 over a1 b2 minus a2 b1, and then you find the value of x, and then you do the similar thing with y to find the value of y. Okay, so let's see an example of this. So let's say you have an equation 5x minus 3y equal to 7, and another equation is 4x plus 2y equal to 8. Yeah. So what you're going to do, you're going to do x is equal to, b1 is nothing but negative 3, c2 is negative 8, minus b2 is 2, and c1 is negative 7, equal to 1 over a1 is 5, b2 is 2, a2 is 4, and b1 is negative 3. Okay, when you calculate this, you get what? X over 38 equal to 1 over 22. So x is equal to 38 over 22. When you do the simplification, this becomes 11, this becomes 19. So 19 over 11 is your x. And then you put this value in the equation to find the value of y, or you can use this equation to find the value of y. Okay. So great job today. That's all for today. Let's recap what we learned quickly. We did linear equations in two variables. So when the highest degree of equation is 1 and we have two variables in the equation, it is called linear equations in two variables. We did graphical representation and the types of solution. There are three types of solution: unique solution, which is called consistent system; no solution, which is inconsistent system; and infinitely many solutions, that is dependent system. We also did algebraic methods to find these solutions. We did substitution, elimination, and cross multiplication. So these are the key points in this chapter. And here are the 10 practice questions for today. Now your task is to solve these practice questions before the next video. Drop your answers in the comments and I'll see you in the next lesson. Until then, keep studying. Good luck. Bye-bye. If my video helped you in your preparation for your board's exam, do like, share, subscribe, and comment to let me know. Also, share this video with all your friends and family who are preparing for 10th boards. And tune up for the next chapter in my next video.